Hi, in this video we're going to talk about how we estimate the error in the result of a calculation, taking into consideration the errors associated with the values we use in our calculation. But first, let's review how we go about reporting a measurement. In a previous video we had said that somebody measuring the length of this pencil could reasonably report that length as being 6.35 centimeters. And given the convention we had established, somebody reading this value would know that this is an estimated value here. So this digit is unreliable. So it's 6.3 something. And that the rule of thumb was to say, well, the error is half the smallest interval. So somebody looking at this would say, oh, well, this value really is somewhere between 6.3 and 6.4 centimeters. Now, reporting a value in this way is not totally wrong, but it is not quite proper. It is expected that an experimenter explicitly state the maximum error associated with a recorded value. Stated this way, there is no doubt that the experimenter believes this value to be off by no more than half a millimeter. However, it's quite reasonable that an experimenter might look at this and claim an even smaller range of uncertainty. Such an experimenter may record the length in this way. Now this means that the experimenter believes this value is off by no more than 0.2 of a millimeter. So the experimenter is claiming that the length of this pencil is somewhere between 6.34 and 6.38 centimeters. Of course, some other experimenter might claim 0.01. The point is that in both these cases, this digit is uncertain. So let's make sure we understand what these two statements are saying. In this case, the experimenter is saying that the length of the pencil is between 6.3 and 6.4 centimeters. That is, L, the length of the pencil, is greater than 6.3 centimeters and less than 6.4 centimeters. In other words, the length is between 6.3 and 6.4 centimeters. Now in this case, the experimenter is saying that the length of the pencil is somewhere between 6.34 centimeters and 6.38 centimeters. That is, the length is greater than 6.34 but less than 6.38 centimeters. In both cases, the experimenters report values that are precise to the millimeter. It's only in the tenths of a millimeter that they disagree. Of course, they also disagree as to how uncertain they are. They provide different ranges of uncertainty. The experimenter who recorded this value is claiming a greater degree of certainty. Let's now define a few terms. When, as in this case, the experimenter records a value, say in this case 6.35, we're going to say that this is the nominal value and that this is the maximum possible error. The nominal value is 6.35 centimeters and the maximum possible value is plus or minus 0.05 centimeters. Sometimes this is referred to as the maximum absolute error. This can be quite a mouthful, so very often you'll hear people just saying absolute error. And so if I say, oh, the absolute error is 0.05 centimeters, please understand that to mean the maximum possible error. It's a range. You can never know exactly what the error is. If you know what the error is, then it's not an error. You just add or subtract it from the value. So what this is giving you is the range. So you expect this to be off by no more than half a millimeter. So it's a maximum range. This could be up to 6.4 or down to 6.3. Let's look at the notation. In physics, you have to learn notation. There's no way around that. So one way to say this in general is just to say, for example, that the length is equal to some nominal value plus the maximum possible error. So again, this is the nominal value and this is the maximum possible error, or the absolute error. Another important term is relative error. In this case, the relative error is going to be 0.00787. Notice we don't have any units here because these cancel. Sometimes it's preferable to express this as a percentage, so this would be 0.787%. And we should put plus or minus here, of course. So how do we get the relative error? We simply divide the absolute error by the nominal value. So the notation we often use is this one. This, of course, is going to be equal to plus or minus delta L over L. And if we want to, we can express this as a percentage, so we can say times 100%. So let's just recap the terms you should be very familiar with on completing this tutorial. So given any measurement, let's just use the symbol m this time, for no particular reason. So we can say when we make some measurement m, we have some nominal value plus or minus some maximum possible range. So nominal value, need to know this term, absolute error, or maximum possible error, and relative error. And remember, this can be expressed as a percent. So the nominal value in a case like this is just simply m. The maximum possible error here is plus or minus delta m. And the relative error here, the symbol is percentage m, if you're going to express it as a percentage, and that's going to be equal to, so nominal value, maximum possible error, and relative error. Remember, sometimes I call this absolute error. So how do we use these to estimate the error in a calculated value? Well, that's what we look at next.